What physics?
It's just physics.
God, that's terrible. If they would have tested me on the first day, I would have.
I don't know yet. I haven't done these. I'm going to do them right now. Don't you like that? I don't know the answer key.
I forgot everything from physics 140.
I'm going to make the answer key right now. All right, guys, let's take a look at these. Bring it with you, Jim. There you go. Hopefully the first two weren't that crazy. You haven't done a lot of stuff with 3D yet, but you guys know 1A and 1B exactly the same procedure. You guys know that? You guys have done some 3D stuff, believe it or not. Normally you do see the 3-component distance formula at some point before this. 1A might be a little freaky. Oh, my board's got freckles and streaks. 1A might be a little bit freaky, but what is that? Oh, neat. Let me see if you guys can see that. It's going to take a little getting used to as to where to put this camera. All right. But how do you set up 1A? Yeah.
X squared.
X squared.
Minus X.
Plus 1.
Oh, there we go.
Minus -1, right? You got to do the difference in the y.
Squared.
Squared. I love it. Because it's based on what? Pythagorean theorem. I love it. Right? Which Pythagoras took credit for, and his followers actually did a lot of the work. That's the way it just goes. Yeah, what's the other?
Plus 3 minus x squared. 3 minus x.
3 minus x would work? But I would rather just look at that, but they're both the same, right? If you flip them inside a square, the sign changes, the square don't give a shit. Makes it all become the same at the end. And now, really, it's just, foil it out and get your stuff together. No big deal. Right? There wasn't too much simplification you could do, I don't think. Right, some guys looking like we're but it's just x of 4.
Plus 3x squared minus.
Oh, so yeah, after you bring in that guy, so plus 2x squared, plus 1, plus.
This one minus this one.
Is that cool? And then you put the like terms together. Cool. I like it. I really wanted to see if anybody, if you did this, keep it to yourself and never did it again. Do you understand why somebody would do this incredibly heinous thing here? Yay! Look at that. It's beautiful. How did this person do that?
There's no parentheses?
What did they do? They took the square and the square root, and they somehow killed the squares, right? And this is what kills me with my calc students. Some of you guys were my calc students, but I might not be talking about you. They do stuff like this, and they say, "Well, that's obviously this." Next, yay! Trig sub. I never had to do trig sub ever. Oh yeah. So please, dear God, this is just the idea that radicals are powers. And powers don't play well with subtraction because they're based on multiplication, right? They play well with multiplication. So what do I mean by that? 9x squared, square root, I can do. Yeah, I can distribute across the multiplication because exponents are based on multiplication. I can't distribute across the subtraction because they ain't based on subtraction. It's that simple. That simple. But that's such an easy little thing that your brain says yay, and you got to stop your brain and say, brain, no. Shit, we just got to deal with this thing. It's one of the most common mistakes I see. Makes problems easy and very quickly wrong. All right, I've lost interest. Just put your like terms together. 1b. How do you set this guy up? It would just be
2 plus 5 squared.
Yeah, exactly. So 7 squared plus. What's up? Is that very cool? So 2 plus 5 squared.
Oh, sorry.
That's all right. Plus 3 plus 0 squared. Plus. Or 3 minus 0 squared.
Negative.
Negative 3. Yeah. Negative 1 minus 2 squared. I like it. Okay, cool. So then you get 49, 99, 18, 67. I like it. You just stop there. All right, cool. I just wanted to see if you guys could either make that jump yourself, or at some point you guys have seen that. I can't remember what class we teach. I think pre-calc or somewhere we do this extended distance formula. So if you went to 87 dimensions, which you do in later classes, you go to n dimensions actually. Any you guys listen to Pandora, by the way, while I'm thinking about it? Pandora is amazing. When I teach linear algebra, anybody got to take linear algebra? That's where you start talking about arbitrarily sized dimensions, which is freaky to us because we live in the third dimension. We live in 3 dimensions that we can experience directly. There might be more that we actually live in that we just don't see or interact with directly. That might have blown your brain. Do some string theory stuff. Look at that shit. But Pandora, if you say you like this song, it identifies, for jazz, there are like 400 components to that song that it identifies. So it's 400 dimensional space. And then it says this song is this close to it. It calculates distances between all the length, well, we're not there yet, but all the vectors that represent all the different components of the music. And it says, this is really close to this, what you liked. Let me play it. And then you say, I don't like that one. And then Pandora goes, oh, it went the wrong way. Let me do this song that's on the other side of this thing, and let me try that. And it just kind of tries to narrow in on what it is that you like about that song. And do you guys see that? That's beautiful.
You can represent music as a vector.
Yeah, the different components. I'm not going to profess, I can't even play triangle really well, but if there's a musician out there, you guys know, like the percussion, how prevalent is the vocal? Is it kind of back or is it in the front? There's all these different variables you can identify with music, and jazz actually has one of the most sets of variables, believe it or not, especially if there's vocals involved. Yeah.
Yeah, so what they do is they basically have an algorithm that analyzes the song file, and then based on the characteristics of it, the beats per minute, the genre, the metadata, what they do is they basically have an array, and they tag everything in an array, and then it gets webbed out. So let's say if you're listening to like hip-hop or rap or jazz or whatever, it has certain tags on it. So it has a certain speed, it has a certain genre, it knows what artist it is, where it came from, and then what it does is once it sees you listening to that music and you like it, it webs out to other content or other array databases that are similar, and then basically that's how they
exactly. When you say array, that is the n dimensions I'm talking about.
Yeah.
One way to represent several dimensions is with an array. You could use matrices if you start talking about dimensions within other dimensions.
Spotify also does that.
Tensors.
That's how you guys, not just in music, but in a lot of stuff, you get like recommendations based on things you like.
Exactly.
Is, as you said, an array, but it's more that it's like it'll check for specific, like for Pandora, it breaks it down to like, is there a vocalist, is there all that stuff.
It really breaks it
But if you're on
down.
the computer, you can actually check what criteria each song has to see why.
Well, they tell you the upper level criteria, but they break those down even further. Netflix, I think, just says you like this movie, had somebody named Bruce in it. This other movie has a Bruce in it. Maybe you'll like that. What it seems like to me, I don't know. All right. But that's just something interesting, you guys. A lot of you guys know Pandora. Some of you guys use Pandora. And it's just so cool that there's this upper level math that's behind it that most people usually don't understand and don't even know it's there. They're like, how the hell does this thing work? Okay. Did I finish that one? Oh, yeah. Square root of 67. So help me out here. What's the derivative of 6 to the x? Let's start with that. 6 to the x.
ln 6.
And of course that explains why this guy's derivative is itself, because it's e to the x ln e, and ln e is 1. Yeah, so you just get e to the x. I love it. So think about this. I don't know how you've been taught basic integration, but I like to teach it as kill the thing you don't want to be there. So if I thought the answer to this was 7 to the x, well, when I take this guy's derivative to check that, I'm going to put the plus c, when I do the when I take the derivative to check it, the derivative would have times ln 7. Is there an ln 7 here?
No.
So I better do what so that it dies? I better divide by ln 7 so that it dies. Right? That's why when you integrate e to the 2x, what do you get? Oh. It's a weird reaction.
E squared. Oh, wait.
That's what you get when you take the derivative, is 2 e to the 2x. So when you take the integral, it's got to be e to the 2x divided by 2. To kill the 2 that would want to come out when you take the derivative. I don't know if anybody was taught that way. I like to teach it that way. I think that's the right way to think about it. Until you get to the more advanced functions where you have to use u sub because there's too much to kind of keep track of. I could use u sub here, but why the hell would I do that? It's a linear function inside. I don't need to go u sub. I can handle linear function wherever the hell they are. Maybe. All right. So, there you go. Interval 7 dx should be 7x divided by ln 7. Kill that ln 7 that wants to come out. Yes. That's really just to remind you guys, yes, that will come up, possibly. You got to know your derivative stuff, even the more obscure ones. What about now 2b? There's two main ways to do 2b.
Why did they use sub?
You did use some, I like it. That's the smart way to do it.
Trig sub, but it
What else did you try? Sorry.
trig sub.
Now, why won't trig sub work?
I got a square.
What does trig sub need in it for the identities to work? A square. And x is not squared. If x were squared, it would be so obviously what? If it was this, it's an obvious what kind of problem? U sub. You could use trig sub, you could. But isn't the inside function a degree higher than the outside? That means a derivative would become it? That's what you look for to see if it's a U sub possibility. Now this is a hidden U sub, right?
Yeah.
Crouching U sub, hidden. Oh my God. That's bad, Jeff. It's bad for you. The reason I like to show this problem is because a lot of times teachers don't think to show you this. But I make certain to show you this. You've got to understand the flexibility of U sub. It's more powerful than you realize. Once you start to learn by parts and so forth, you're like, U sub can't do much. It can do more than you think. If I let you, why don't I want to let u be square root of x plus 1? What quickly tells me that's not a good idea? Its derivative is not in there. There you go. That's a very quick check. Don't even go down that road further than that, because you're like, its derivative isn't in there. Screw that. So what if I let u be this? Some of you guys are like, well, that's sure, man. And then du is what?
dx.
Some of you guys are still like, where the hell are you going to go now? But if u is x plus 1, x is
U minus
1. Now, do I have everything covered?
Yep.
Yes. So u sub is a substitution process. As long as what you're doing is legal, you need to make all the x's become u stuff. Once you do that, you're golden. Right? So now I can rewrite this as... Now here, I differ from some of my colleagues. I kind of created my own thing. I never liked... It doesn't really matter. Here it's not a big deal. But I never liked changing limits. I just never did. What's bad about that for this class is that a huge part of this class is going to be changing the limits if I want to integrate along the x-axis or the y-axis or the z-axis. I want to be able to change my limits, right? So I'm going to kind of let go. Some of you guys might remember I did this. If you had, it took me for calc. I'm going to talk to you u sub, and I just said that's not going to be the u variable values. I put them in little parentheses to remind me about that. But let's go ahead and just let's get into just substitution. So how do I substitute this so it's about u? Yeah, when x is 0, u is 1. And when x is 3, u is 4. So now I can say that goes from 1 to 4. X is u minus 1. And that'll be square root of u. Now, I was debating on whether to say this earlier or now, but it made more sense now. You can see the idea now is if there were only one term in here, it could distribute. So if only that would have been there and that was there, it would have been easy from the beginning. So that's what the u sub did. It said, well, sure, it's just off by 1. Let's put that off by 1 out here instead of in there. So now it's off by 1 out here. Do you guys kind of see what I'm saying? All right. Yes.
What if you did a u sub as a whole square root and then squared it?
So then you get what u squared is?
Yeah.
So if you said u is this,
And then
but
squared.
then you said u squared is this.
Yeah.
Now you've got to take the derivative of both sides.
And you get
So you get
du.
2 du, 2u du equals
Yeah.
dx. Sure.
And then x equals u2 minus 1. So it's kind of,
Yeah, I think this should work.
yeah, that's how I did it.
Yeah, okay, cool. It'll still work. It's just your limits will be the square root of those.
Yeah, it ended up 1 and 2.
I like it. So there's
Yeah,
always
it kind of
there's always more than one way. Somehow you had to do this,
yeah,
no
it's
matter
a little
what.
bit more work for that, but
And you could even introduce implicit differentiation, right? And that's something else that you're not often shown, that you can actually do implicit differentiation on this step. Sometimes you don't want to. But some implicit differentiation might be a bad memory for some of us. I don't know. Like related rates? The conical sand pie? No? Yes? Yeah, I like them personally. So then here I get what? U to 3 halves. 1 to 4. 3 plus 2 is 5, so it'll be 5 halves. And what's in front? 2 fifths. Is everybody cool with that? You guys, anybody ever show me that? It's a silly little thing, but it's people mess up on that and it's a silly place to make a mistake. I love the faces I'm getting and nobody's asking a question. Do you guys understand what I just did?
yeah.
Some of you guys still making a face, but I'll
Just do it again.
I can't answer a face. So here, 1 plus 2 is, that's crazy. So it'll be u to the 3 halves, and then flip that in front. And I want to go from 1 to 4. And you see why I picked the numbers because they work well with the square roots. So forth, yeah. I like it.
Is that 2 over 5, u to the 5 half?
Yes.
Okay.
Cool. Today especially I'm sort of being a little loose, but I don't write well. I think you guys can see that. So good luck. If I ever get to the point where I had a teacher that actually, when it got down to here, we said, "What'd you write up there?" And he said, "Does somebody remember what I wrote up there?" If I ever get to that point, that's when I need to just retire from a different line of work. I can always read my own stuff still. So, that's good for you, John. So square root of 4 is 2. 2 to the 5th power is times 2 is, all right. Square root of 4 is 2. Cubed is 8 times 2 is 16. And then you can get LCD, blah, blah, blah. I like it. Freakadelic. You guys should all know how to check that in your calculator, too.
Yeah, what about the 1?
What did I miss? Oh, the 1.
Subtraction.
Good job, Jeff. So then minus square root of 1 is, so you get 2 fifths plus 2/3. All right, get LCD, blah, blah, blah. How do you check this? You guys, everybody know how to do intervals in your calculator? Right, it's that 7th option on the calculate, at least in the basic TI-84. I like it. Cool. If you have a calculator that can do symbolic math, like a TI-86 or an 89, I can't allow that. Because it'll do the integration for you, which sounds great. But then the calculator passes this course and you have to take it again. Yeah, what's up? Sorry. You're good? Okay. Yes?
Is it plus 2/3 and then?
No, it's 2/3 because it's plus because it's minus. Of course, you plug that in, and then it's minus. Plug a 1 in, plug a 1 in. So minus and negative is plus. Yeah. Okay, cool. I like this. Sweet. I am not one of those professors that say I never make a mistake, because that's insane. I'm a human, so I make mistakes. So please, dear God, I won't take it personal if you tell me, "Yeah, Jeff, you forgot the entire other freaking one." Beautiful. I love it. Don't let me get away with it. All right. So very cool with that. You guys now, some of you guys know more you can do with USub. I like that. Okay, cool. So what about 3A and B is just a quick check to make sure you still remember your trig, or were you ever taught your trig values? If you had a trig teacher that didn't make you memorize like sine and pi over 3, find them, slap them. What are you thinking? It's crap. So I don't accept that as an excuse. You now know what you got to do if you don't have them memorized. Secant of 5 pi over 6. What quadrant am I in? Second. Secant is related to which likes the what variable? X. I love it. So if you SOHCAHTOA. Anybody know what SOHCAHTOA? Besides, it sounds like I hurt my toe. I'm gonna
Sign opposite hypotenuse.
blah blah blah. Yeah, I love it. I hate it. It gets in your way. It only helps for a little while. If you were taught from the beginning that sine is the y piece and cosine's the x piece, so much shit makes immediate sense. So if you become too dependent on SOHCAHTOA, it quickly becomes irrelevant. You need to know the sine is the y piece, cosine is the x piece, and then a lot of other stuff just falls into place. So I'm not trying to take the SOHCAHTOA away from you if you love it. Just realize you better build on top of that damn thing. Sort of like foil. That shit's got aluminum foil. So if I'm in the second quadrant, cosine, the answer is going to be negative. I love it. And this is like 30 degrees. By the way, you guys in the front row real quick, if you see that bad boy stop, let me know. And then I can, okay, thank you. Because he takes little union breaks. So I really need to know that. So watch how I can rewrite this. I know it's going to be negative. I know the cosine is the reciprocal, right?
Yeah.
And I know the reference angle is 5 or 6 or 30 degrees. So I can always kind of rewrite it. So then I can attack the piece that I got memorized. Right? Cosine of 30 is what? 30 degrees. What's the cosine of 30? Get the bigger one, because cosine likes x. So when it's closer to the x-axis, cosine's bigger. You see that? SOHCAHTOA would tell you that kind of shit. I'm sorry. And it's closer to the y-axis, sine's going to be bigger. I mean, if you think about it, that makes the whole memorization of trig function values easier. So it's really going to be 2 over root 3, which can rationalize to be that. I like it. Which you can check in your calculator, of course. More often, I'm going to prefer the exact answer, not an approximate answer.
Sorry, isn't it -2? Because cosine of 30 degrees is 1/2.
Cosine of 30 is rad 3 over 2. I like it.
I think it's that.
Yes, you are. All right. I was waiting. I like your stubbornness. It's good. Poor Jeff. Yeah.
in the bottom or no?
No.
Okay.
Yes. Thank you. So it's sort of like telling me the answer is 6 over 8. You're like, all right, shit. It's really the same level. If you give me 2 over rad 3, you just haven't finished it. It's not in reduced form. It's not. Yeah.
Will you take off points if we don't have the radical put on the top?
Oh, that's basically what you just asked, right? So yes, we must rationalize those kind of things. Yeah. Because then I might have to want to do something else with this. It's just preferred to have the radical on the top. The radical by itself is gross. So in general, we don't like it on the bottom, causing even more trouble. We just get that bad boy up top.
My teacher also told us how you put it into root 3 groups.
Oh, so yeah, I got 2/3 of a root 3. That kind of thing? I like it. It's easier to kind of estimate in your head. Okay. So any other questions about that? All right. How about part B? What quadrant am I in? Fourth quadrant, so sine's going to be? Negative. So notice this is negative sine. What's the reference angle? Or if you want, or what's it in degrees?
It'd be 1/3 pi. Okay. 1/3.
Yes, right? It's definitely 1/3 of a pi away from the x-axis, right?
Yes.
Okay. So that, if you need to, I don't know. I mean, you can always rewrite it by saying, what's the sine going to be? What's the reference angle? And then you can just attack that problem instead. That's the power of reference angles. And what is the sine of 60? It's the same as the cosine of 30. Holy shit. So it's just going to be... I like it. So at this level, you guys, when I say pi over 4, your brain should just go, that's 45 degrees, without thinking about it. Like when I say snow, you're like, oh, that's the stuff I never see unless I go east when it snows. There's that white stuff from the sky, yeah. You know, just to translate it automatically by this point with the radians. Okay. And then part C, I just wanted to see if you guys remembered this process. with inverse trig, and the idea of inverse functions in general, what do you plug into a trig function normally? Some kind of an angle. So what's going to come out of an inverse trig function is an angle. That's how inverse functions work. One guy's input is the inverse's output. That's number one. So this problem says, I want the tangent of this angle. That's what this really says. I don't know why I put the 3/4 in parentheses. You guys with me? That represents an angle, and I want to know what the tangent of that angle is. So the process I can use to put it in a different format is to draw the triangle that this captures this angle. Now, if you took me for pre-calc, I talked about if you draw the triangle, it might actually not be a physically possible triangle. The math doesn't give a shit about physically possible, do it? No, math gives us the answers for what works in our world and what works in the worlds beyond ours. Right? It just gives us all the freaking answers, and we pick the ones that work. I can't make a shed that's -7 feet long. Right? I'm like, what the hell's that made out of? Don't get too close. You get sucked into the black hole. So just to look at this more concretely for a second. And by the way, not only am I writing a little worse than normal, I'm also going a little quicker than normal. Right? This is all review. So don't be like, oh, every day's going to be like this. So if the inverse sine of 3/4 is some angle, that means the sine of that angle is 3/4. Which means what triangle could I draw that this statement refers to? I know English. Can you make it theta, Jeff? So what's this going to be? 3. And what's like? Sweet. Right? We got to know the basic ratios that this trig function is. Never forget all the shit you've ever done with trig functions. Trig functions are just ratios of sides of right triangles. It's insane the amount of stuff we did when we did that. We set that up. Now be careful, I like somebody referenced 3, 4, 5, but they figured out it wasn't going to be that. It's not that easy, but what is this side going to be? Yeah, it'll be square root of 7, I like it, 16 minus 9. Cool. And now I can answer the question, easy. What's the tangent of this?
3 over 7.
Yeah, 3 rad 7 over 7. I like it. Alright, how are we doing? So, any questions from that little warm-up exercise? If there's any piece of that that you feel very disconnected from, you desperately need to find some examples like that and bring it back up to speed. I'm not saying this is going to immediately become a part, but sine and cosine is going to become a part very quickly. We're going to talk about vectors and the direction that they go in, and they're going to relate to the angles. We're going to have to know how to use those angles correctly. How nice do I want to be the first day? Maybe a little bit. So let me just say one real quick thing, and then I'll let you guys out a little bit early for the first day. I've already used this word a couple times, and I'm hoping some of you guys have worked with this a little bit. What the hell is a vector? What is a vector?
It's a basically an arrow containing both direction and magnitude.
Ooh, sweet. I like it. So we got a little bit of visual in there, and we also got the more concrete definition, right? Vectors represent things that have magnitude and direction. I love it.
It's a ray.
Array, beautiful. So a more basic geometrical definition is it's a ray. An array has a starting point, and it goes forever after that. Now the one difference between an array and a vector is a vector by itself doesn't go forever, but we do draw an arrow to indicate direction. So a vector does not need a coordinate system to exist. Like nothing really does. So do you guys remember those calc problems? Do you remember doing the rotation stuff? Oh yes, you do. Cylindrical shells and washers and discs. And don't worry, they're not going to come back to us yet.
Those are actually helpful.
I know, but there were problems where they had an already formed structure and you had to put your coordinate system on top of it. Do you guys remember those kind of problems?
Yeah.
Hopefully a teacher signed some of those because that's good for the teacher meeting now, right? So I can have something sitting in space and I can take a coordinate system and put it on it any way I want to if it hasn't already been defined. So a vector can just sit here there's a vector. Yay, vector. Now this doesn't mean it goes forever. It just means it points to this point. That's all it really, really means, to be honest. And the longer it is, so if this vector was representing a force, so that would be like me, there's something here and I'm pushing on it with this much force, right? And then somebody else says, all right, I'm going to push on this with this much force, and they're going to get the gold. I might get the bronze. Or the silver, maybe. Right? Sorry, I'm in the Olympics mode. You guys kind of with me? Does it look roughly like they're pointing in the same direction?
Yes.
All right, good. You got to give me a little board license, right? So if I called this U, maybe this is almost, let me make this a little bit longer. 2U maybe. Hold on. So some of the math involved with vectors is stupid easy. Some of it, not so much. But we can, in a lot of situations, we could think about vectors as force. Somebody's pushing on something. So if I had this vector, what do you think this vector is?
Negative.
So if both of these forces are acting on an object, if I add those vectors together, they should come out to be the zero vector, right? And I love it. If you ever seen, I remember, here's the last little anecdote. There was a billboard that would show wind speed. You with me? So it was like 3 miles per hour from the southwest, right? And then I was driving by and it said 0 from the northeast. Okay. Right, but of course it's like the